Section 8.3, we're going to show that a quadrilateral is in fact a parallelogram. We talked about properties of parallelograms yesterday. We're going to look at those properties and what necessarily would make a quadrilateral a parallelogram. And I basically just listed these all out as bullet points here. If any of these things occur in a quadrilateral, then the quadrilateral is a parallelogram. First of all, if you see both pairs of opposite sides being parallel, well, of course it's a parallelogram by the definition of parallelogram, was that both pairs of opposite sides had to be parallel. So that's one thing that might happen that would prove, yes, this is a parallelogram. Or if you see that both pairs of opposite sides are congruent. That is enough info to say, yes, this quadrilateral is a parallelogram. Okay, both pairs of opposite sides being congruent. The third criteria, if you see both pairs of opposite angles are congruent in a quadrilateral, then it is in fact a parallelogram, both pairs of opposite angles being congruent. Another one, if you see one pair of opposite sides, okay, like one pair of opposite sides are both congruent and parallel, that would be enough info to know for certain that that quadrilateral is a parallelogram. That's one pair of opposite sides being both congruent and parallel. And the last one is if you see a quadrilateral where the diagonals bisect each other, meaning they cut each other in half, then that quadrilateral is in fact a parallelogram. So you should have these 5 things written down and be ready to use any of those today. All right, first example. So this is part of a stair railing. If you imagine like there'd be stairs here going up, and this is where you'd put your hand to help up the stairs there. So how do you know that the support bars MP and NQ are parallel? MP and NQ. Okay, these are my support bars between the bottom of the railing and the top here. Well, how would I know that those are parallel? If I could show somehow that this is a parallelogram, then by definition opposite sides would be parallel, right? And then those would be parallel. I guess, is there enough info here to show, as we just talked about, that this is a parallelogram? Well, if you notice, both of these support bars are 3 feet. The distances between those bars are 2 feet on top and bottom. Isn't that the case where I have both pairs of opposite sides being congruent? I could put tick marks here on the opposite sides, and look at that. Yes, both pairs of opposite sides are congruent. So I know, in fact, it is a parallelogram. Both pairs of opposite sides are congruent. So we have a parallelogram. Remember how we're ultimately trying to show that those are parallel. And if we have a parallelogram, then by definition, the opposite sides have to be parallel. So, opposite sides, MP and NQ, the ones they wanted to show, are parallel. So I'm going to say MP is parallel to NQ by definition of parallelogram. Okay, so I had to show it was a parallelogram using one of my new special properties that both pairs of opposite sides were congruent, therefore it is a parallelogram, and by definition a parallelogram has opposite sides being parallel. So yes, those support bars are parallel. Using one of our properties there. Both pairs of opposite sides were congruent, and then we had a parallelogram. Alright, in quadrilateral WXYZ, the measure of angle W is 42 degrees, the measure of angle X is 138 degrees, measure of angle Y is 42 degrees. Find the measure of angle Z. It's the only angle we don't have. And then, is WXYZ a parallelogram? Explain. Well, I'm going to sketch out, I guess I'll just use my pen. I'm going to sketch out possibly a parallelogram. Okay, I don't really know. It's asking me, is WXYZ a parallelogram? W is 42 degrees, so I could start here. That would look about 42 degrees. W, X, Y, Z. X was 138 degrees. Y is 42 degrees. It says find the measure of angle Z. Now here's the thing. I don't know this is a parallelogram yet. That's what I'm trying to show. So I don't know that it's 138 degrees. Okay, I don't know whether it's a parallelogram or not. What do I know for certain about the angles in a quadrilateral then? Because that's what I could use to find this missing angle. I know for certain the angles in a quadrilateral add up to what? They add up to 360, right? So I'm going to do 360 minus the angles I have, and I'm going to see what angle Z would have to be. So I'm doing 360, I'm subtracting 42, I'm subtracting 138, subtracting another 42. Okay, angle Z is 138 degrees. All right, so I found measure of angle Z. It is 138 degrees. And why am I excited about that? Because look, the opposite angles in this quadrilateral are congruent, and that was one of the reasons here. Both pairs of opposite angles are congruent, therefore it is a parallelogram at this point. But again, I didn't know that was 138 till I just did 360 minus what I had. But once I had both pairs of opposite angles are congruent, so we do have a parallelogram. Because that is one of our properties that works. Okay? New example, and I put the notebook paper in the background for a reason. It says you put two straight lines of equal length on two lines of your notebook paper. If you draw a segment to join their left and right ends, will the resulting figure be a parallelogram? Explain. Okay. I put two straight lines of equal length on two lines of notebook paper. So I'm going to do, what did I do? Blue line here. Two lines of equal length. So I'll do this line, and I'm just going to copy and paste it so I know it is actually equal length on two different lines. So I'll do maybe this line. Draw a line segment to join their left and right ends. So I'll draw this line segment to join their left ends and this right line segment to join their right ends. Can't talk. Well, is this a parallelogram? Explain. All right, let's see. Remember how the straight lines were of equal length? So I know that these are congruent. I can put tick marks. And if this is notebook paper, what do you know about these two lines on the notebook paper? Don't they have to be parallel? It's the way the notebook is designed. So I also know that these sides are parallel. At this point, I guess that's all I know. I know that I have one pair of opposite sides being both congruent and parallel. And if I go back, that is another one of those properties that proves a quadrilateral is a parallelogram. One pair of opposite sides are congruent and parallel. This one pair of opposite sides is congruent and parallel. So yes, it is a parallelogram for that reason. And today, when you're supposed to give a reason, I just want you to write it out. You'd say, is a parallelogram because, and give the reason. In this case, actually, is because one pair of opposite sides. Hopefully your handwriting is better than mine. This is real good right now. Sorry. Because one pair of opposite sides is both congruent and parallel. And that's enough to show that that is a parallelogram. Okay, and one more example for you. In this case, you're supposed to find what value of x would make RSTU a parallelogram. For what value of x is RSTU a parallelogram? So I notice I have what looks to be maybe a parallelogram. What x would make it one? Well, notice we have the diagonals drawn in here. And for a quadrilateral to be a parallelogram, the diagonals have to bisect each other. Well, this diagonal is for certain bisected because I see the congruent tick marks here. Is this diagonal for sure bisected? Well, I don't know. But I do have these expressions, so I know that if these were congruent, this thing would be a parallelogram because both diagonals would be bisected. Well, then to find the x that would make that true, what do I need these two things to be? I need them to be equal, don't I? So that it's bisected, so that those are congruent. So I need 8x minus 32 to equal 4x. And now, solve for x, do the algebra. X is on both sides, so I'm going to subtract 8x, get rid of it from there. 4x minus 8x would be a negative 4x, and divide by negative 4 on both sides. Negative 32 divided by negative 4, and of course it does turn positive, so no big deal there, and x equals 8. And the reason why this value of x would make it a parallelogram is because right now we need both diagonals to be bisected. Okay, I'm combining diagonals and bisected. I'm having writing problems today. I'm just gonna start over a little bit. Need diagonals to bisect each other. And I found the value of x so that that did happen. There you go. So today, using those 5 reasons to show that a quadrilateral is a parallelogram, First of all, both opposite sides parallel. That's the definition of parallelogram. Both opposite sides congruent. Both opposite angles congruent. Or one pair opposite sides congruent and parallel. Or diagonals bisect each other.